Okay, welcome back to the class on exercises. So we're dealing with exercises for work, energy, and power today, and of course we have 6 questions today to solve. So let's begin from the first question. Okay, a farmer uses a constant horizontal force of magnitude 21 newtons on a wagon and moves it a horizontal displacement of magnitude 3.2 meters. How much work has the farmer done on the wagon? Okay, so what are the parameters we've been given? We have force to be 21 newtons. We have distance or displacement to be 3.2 meters. And we're asked to find work. Okay, so we know work is force times distance, right? So, of course, if the man applied a force of 21 newtons through a distance of 3.2 meters, of course, we have 21 times 3.2, which gives us 67.2 joules. All right. Note that the force applied on the wagon was a horizontal force and the displacement was a horizontal displacement. There was no component involved. It wasn't tangential. The forces were horizontal, and so we had to use straight formulas without any angle or anything. Okay. Now the second question is: a 1000 kg elevator accelerates upwards at 10 meters per second square for 10 meters, starting from rest. How much work does gravity do on the elevator? So parameters are 1000 kilogram for mass, 10 meters per second squared for acceleration. We have d to be 10 meters. All right. So we have displacement to be 10 meters. We have gravity to be 10 meters per second squared. We're asked to find the work. So the force acting on this elevator is just gravity alone. So we're asked to find the force of gravity. So if we have this like a free body diagram, we have 1000 kg, which is the mass of this elevator. Okay, so we're asked to find how much work is done by gravity to oppose this motion. So we have force of gravity equal to mass times acceleration. So that would be the mass of 1000 grams times 10 meters per second squared, which is 10,000 newtons. Okay, so we know we have a force of 10,000 newtons pulling that elevator downwards. Okay, so this elevator moved 10 meters. So simply our work will be force times distance, which is 10,000 newtons times 10 meters. So we know that gravity did a work of 100,000 joules, 100 k joules on that object. This elevator is moving upwards at 1 meters per second. All right, and this motion is continued for 10 meters. We are asked to find the work of gravity on this body. All right, and we know gravity, the work of gravity is going to be done to pull this body down. But here the body is actually moving up. So we just want to know what work of gravity was done on this body. And that we have found. Question 3. A 68 kg inline skater starts from rest and accelerates at 0.21 meters per second square for 15 seconds. Find her final velocity and total kinetic energy after the 15 seconds of travel. B. If she exerts a braking frictional force of 280 newtons, find her stopping distance. Okay, the parameters we're given here is mass 68 kilogram. We have acceleration for 0.21 meters per second squared. We have time as 15 seconds. We're asked to find her total velocity. Okay, and the kinetic energy after she has done 15 seconds. Okay, so that's why our time there is 15 seconds for the first question. A, we have to think of what formula to use to get velocity. Okay, that's the final velocity after 15 seconds. All right, we know her initial velocity. We know her initial velocity is 0, which you can see here. It starts from rest. So we'll use the formula v equal to u plus at, where initial velocity is 0. Acceleration, of course, we have that to be 0.21 meters per second squared, and we have our time to be 15 seconds. So if we solve that, we have 3.15 meters per second as the final velocity. So we are also asked to find her kinetic energy. Of course, we know kinetic energy is half mv squared. All right, we have her mass. Now we have her velocity. Okay, so we can use that to find her kinetic energy after 15 seconds. So we're using 3.15 as our velocity because that's her velocity after 15 seconds. And we are asked to find kinetic energy after 15 seconds. So it's only wise we use 3.15 as our final velocity there. So we have half times 68 kilogram times 3.15 squared, okay, which gives us 337.4 joules. All right. So B, if she exerts a braking frictional force of 280 newtons, find her stopping distance. All right. So first of all, for a braking frictional force of 280 newtons, we need to know the deceleration. Okay, we need to know the deceleration that braking force can give us. If we know the deceleration, then we can, with that deceleration, find how long that deceleration will take place. So we have the force of deceleration, all right, and we have, that's the braking force of deceleration, which is 280 newtons, and we have her mass. So we can use force equal to mass times acceleration to get that. So acceleration here is force over mass, which if we put into this equation, we have 280 newtons divided by 68 kilograms. All right, which if we solve for, we're going to have a deceleration as 4.118 meters per second squared. Now we have our deceleration. Can we find the distance this deceleration will take to bring her to a stop? Okay, so in that case, we have our deceleration. Okay, we have our initial velocity, which is the 3.15 here. That was the final velocity here. Because we are now decelerating, it will be the initial velocity now, and our final velocity will be 0, because that's where we hope to end. We are supposed to come back to a state of rest after deceleration. So we're going to use the formula v squared equal to u squared plus 2as, where v squared is, of course, our final velocity, which is 0. U squared is our initial velocity, which is 3.15 meters per second, all squared. Then we have 2 times acceleration, which is going to be the deceleration. So this positive will have changed to negative, because this will not just be positive, it will be minus 4.118 to show its deceleration. Then we'll now have to find s. So if we do that, we have 0 equal to 3.15 squared plus 2 times minus 4.18 times s. All right, when we simplify that, we're going to get 8.236s d equal to 3.152. Okay, this comes over to this other side, so it loses the negative sign. So we have 3.15 squared. All right, so if we make s the subject of formula, we have 3.15 squared divided by 8.236, which gives us 1.2 meters as her stopping distance. So let's move to number 4. We have a girl climbs a long flight of stairs. She travels a horizontal distance of 30 meters and a vertical distance of 14 meters. If a change in gravitational potential energy relative to the ground is 6,800 joules, find the mass of the girl. To understand this question very well, okay, there's a flight of stairs, let's say this way, all right, and we can do something like this. So this is we have the flight of stairs. Okay, the girl travels a horizontal distance, so we have this length to be horizontal distance, and it's 30 meters, all right, and a vertical distance of 14 meters. So this is 14 meters. Okay, so at this ground point, PE for the lady is equal to 0, all right, while at the top here, PE for her, I'm doing this so you guys can get to understand the question properly. P is 6,800 joules at this point. So we're asked to find her mass. Okay, this is simply a case of change in potential energy. All right, so we can find her mass if we know the formula for potential energy, which is mgh. Okay, first of all, these are our parameters here. We have horizontal distance 30 meters, vertical distance 14, then potential energy 6,800 at this height. We have to find her mass, so we use the formula potential energy equal to mgh. Okay, so we have the potential energy, we have the gravity, we have height, and we have to find mass. So we know that height in this case is the vertical distance, which is 14 meters. So we bring that into the equation. We have m times 10 meters per second squared times 14 meters. All right, so we make m the subject of formula, and we'll have 6,800 joules divided by 140 meters squared per second squared. All right, which would give us 48.57 kilograms. Okay, so that's pretty straightforward. All right, so number 5, we have a man pushes a drum of oil 10 kg up an inclined plane. If OA is 5 meters and AB is 3 meters, what is the potential energy of the drum at A? What is the work done by the man? And what work is done if the drum is just lifted from B to A? Okay, so to solve this question, what is the potential energy of the drum at A? Of course, the potential energy of this drum at this point is going to be mass times gravity times height. So we have the mass of the drum, which is 10 kg, multiplied by gravity, which is 10 meters per second squared, multiplied by the height, which is 3 meters. So if we do that, we're going to have, of course, 300 joules that we can see here. 10 kilogram times 10 meters per second squared times 3 meters will give us 300 joules. Now, to find the work done by the man is still same thing, because work done when we talk about potential energy is still mass times gravity times height. So we're going to have same answer, 300 joules. Now, the third question is, what work is done if the drum is just lifted from B to A? All right, let's not forget what we had was something like this. Okay, where this is A and this is B. So the question now is, what work is done if the drum is just lifted straight from B to A? Okay, without using this incline. If it's just lifted from B to A, what work is done? We still have the same thing, the same formula for work, mass times gravity times height. So the mass remains 10 kg, gravity remains 10 meters per second squared, and the height remains 3 meters. So what's the work done? Same thing. So we're going to have the same answer all through. So the last question, at what height above the ground must a body of mass 10 kg be situated in order to have a potential energy equal in value to the kinetic energy possessed by another body of mass 10 kg moving with a velocity of 10 meters per second? So let's first of all find the kinetic energy of this 10 kg mass. All right, so if we do that, we're going to have kinetic energy equal to half mv squared. All right, if we bring in those values, we have half times 10 kg times velocity, which is 10 meters per second, all squared. Okay, so if we simplify that, we're going to have 500 joules. So the question now is, at what height above the ground will a body of mass 10 kg be positioned or situated in order to have a potential energy equal to 500 joules? So of course, we bring back our potential energy formula, which is mgh. We know we are dealing with 500 joules of potential energy and we want to get the height. So this will be 10 kg times 10 meters per second squared times h, which of course, if we make h the subject of formula, we're going to have 500 joules divided by 100 kilogram meter per second squared, which would give us a height of 5 meters. I believe these things are straightforward. That's why I'm not really taking so much time to explain so much. But if you have any issue or you don't understand anything, you can always drop a question either in the comment section or through our contact link, and we'll get back to you with explanations.